Hi gang, we had just done the upper and lower sum for y equals x squared, and now I want to just propose, I want to just go over like a concept or an idea. This is a different technique than I just taught you. This is what we would call the they're using the midpoint to create the rectangles, which is sort of cool. I don't know if you guys can see that. Like we were using either the left side or the right side. They're actually using the center. And also their function isn't like strictly increasing or decreasing, right? It's coming down, then it's going up. So let's look here. They have about 1, 2, 3, 4, 5. They have 5 rectangles trying to estimate the area under this curve. And I can't quite see here, but I'm going to guess about 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay. Now they have the same curve, but they're using 10 rectangles. And here I have no idea how many that is. I want to say 50 off the top of my head. I don't know. A lot. Now, it's the same curve. It's the same procedure, which is using the midpoint to form the height of the rectangle. The only difference between these three is that the number of rectangles they're using. So, in your opinion, which one do you think is going to give the best estimate of the area? Do you think it's number 1, number 2, or number 3? Which one of these three do you think is going to give the best estimate of the area? And why? Why is it giving the best estimate of the area? All right, so out of the three, the one that's going to give the best estimate of the area is this one, the third one. And you might be able to see it, right? Because you can see the error on the first one, for instance, like this should be colored in here. This is too high, right? You can see the error above and below. The error above and below the curve gets smaller here, and you just almost even can't see it over here. There still is. I mean, if we zoomed in, we'd find it, but because you are still estimating here, but the error has gotten very, very tiny. So the reason that this one is the best estimate of the area is because it's using the most rectangles. And the more, so the logic is, the more rectangles you use, the more you minimize the error, the E-R-R-O-R, the error, okay? So then the question is, and this is the jump I want you to make, is, well, okay, if this is the best estimate here because it's using more rectangles, how many rectangles do I need to use then to get the exact area? How many rectangles do I need to use to get the exact area? I want you to think about that for a second. Okay, the answer is you want to use an infinite, yes, I said that, an infinite amount of rectangles. So now you're like, well, how do we do that? Well, I'm glad you asked. I am glad you asked. Because here we go. All right, so do not get intimidated by this stuff. This stuff, you know, has more bark than bite. Let's take a look at this and see if we can understand it. This right here is the width of a rectangle. So maybe let me back up a minute. This right here is the area of a rectangle. This is the width of it. This is the height of it. This is the width of it, right? Base times height. Or length times width. This is the width of it. This is the length of it. So this is the area of one rectangle. This, if you've never seen this before, this guy is sigma. Sigma, what sigma does is it adds up things. So like this is sigma at work right here. It's adding the first rectangle plus the second rectangle plus the third, on and on. That's what sigma does. It says, okay, if this is one rectangle, I'm gonna add up all your rectangles. How many rectangles would you like? This is where it gets good. How many rectangles would you like? You'd like n? Okay. N is going to who? N is going to where? N is going to infinity. So how many rectangles is that? That's an infinite amount. And that's exactly what you need to calculate the area. I don't know, I think that's pretty cool. I hope you guys do too. So when I come back, what I'm going to do is break this process down for you into bits. So I'll sort of examine the pieces individually, and then we'll come back and we'll put it all together so we can examine the area. And then let's come back and find the exact area of that problem I did in video 1 and 2 and see what it is, because we only estimated it. All right, gang, let me end this here because this is more like the concept. I want you to understand the concept of what we're doing. So then in the next videos, we'll like mechanically crunch it out. All right, catch you soon. Bye-bye.